And hello everyone, welcome back to another C++ tutorial. So in this tutorial, I'll be showing you all how to execute Lua code inside of your C++ program. I've said many times before, it's really easy to do this, but I've never actually shown you how to do it. So let's get started with that. Now, first of all, if you want the code, it will be here in WeebNet2 YouTube projects. This link should be in the description. If it's not, just leave me a comment and I'll remember, hey, that should be in the description, and I'll add it into the description. You'll find it inside of this C++ folder here. Currently, there's only one thing in here, but I will add it after this tutorial has been filmed. You can just click on here then, and boom, you should be able to open up here and you should be able to get the code if you need it. Otherwise, you can just follow along and we'll be good to go. This link will also be in the description. This is the library we'll use to run this C++ or to run Lua inside of C++. You'll have to go to this right here, this link, and you have to go to code, and you can either download a zip file, get it via SSH, GitHub CLI, or you can just use the regular HTTPS method. I like this method because it is very easy to clone. Okay, once you've chosen your method of downloading this, you want to go to your downloads folder or wherever you want this source code to be. And you just want to say git clone. This is if you're doing the same method as me. Git is a version control system. It's very well integrated with GitHub, so we can use Git to get code from GitHub. If you do this, it will download the code onto our PC. Now, if you're not great with the terminal, all I did is I just downloaded the code. Here we go. All I did is I downloaded the code here in my downloads folder. See, LuaCpp, and here's the code. You should see the same. Next up, what you need to do is you need to go into this folder. So in my terminal, that would be cd for change directory, LuaCpp. And before we continue, this method we're going to use in this tutorial is primarily focused on Linux and Mac OS like operating systems. So if you're on Windows, you might have to do a few steps different, which I don't know which you should do different, but you could go to these people right here, just create an issue and ask how do you use this on Windows if there's not already an issue on it, and they might tell you how to use this on Windows. However, they should be fairly the same process, just a few minor differences here and there. And I believe if you got C++ to work on Windows without any issues, you'll be smart enough to figure that out on your own. Alright, so here's my code and here is my terminal. Now what we have to do is we have to create a build folder. So mkdir build. As you can see, there's now a build folder. And just go into that build folder. And now we need to make the things here. So we can say cmake. I assume you have this installed if you watched my cmake tutorial. And we can just say source. And this will make everything buildable in here. As you can see here, it has created everything we need here. If we were to ls here, you'll notice we have a bunch of cmake files. Now what we need to do is we need to say make-j, and then in these quotation marks, these are like backtick quotation marks, usually right next to the one on a US QWERTY keyboard. And then you can say in proc. Do that and it will build the entire project for you, and all you need to do is just wait. Now take note, you do need Lua installed for this to work, at least the development files, because you'll need to link the development files in the compiling process when you compile the program. We'll get to that, but just note you do need Lua, or at least its development libraries installed. I have Lua's development libraries of Lua 5.3 installed, so I'll be using that. However, this does support Lua 5.4, so if you have those libraries, then you're also good to go. While we wait for that, let's build our code, or let's code out what we need. Alright, so we'll clean up a little bit, just plop. Okay, so here's our basic program that we usually have. So first of all, we need to include the Lua C++ development libraries, which you will not have installed yet, but I actually already have this installed. So hashtag include LuaCpp right here. You might have to tell VS Code where to find this LuaCpp. So we can just go quick fix and we can edit include path settings. And then right, I think here is where you need to change it. So for me, the Lua path, I believe, would be somewhere that's not completed yet, so I can't use that terminal. Let me just open up a terminal here then. It should be somewhere around here. So from my root directory, usr local include, and we should have LuaCpp. If you have installed it, we have not yet completed the installation here, but once you have completed the installation, you should see something similar to this. If you see a lua.hpp, you're in the right folder. So we just need to go here, just need to copy that and then plop it in here. So boop. And now we should be good to go without any errors. And we might just want to say .hpp. And for some reason it did not save it. And it is not saving it still. And I think we have to go to this right here. And yes, now all we need to do is we add this. And there we go. Error is gone. And that worked. So all you need to do is you need to go here, click on this one right here. You didn't change it in here because it doesn't seem to work. Go here and you just edit your include path to include LuaCpp. And this is after this has finished installing, of course, or compiling and stuff. And then back in main.cpp, we can start our coding. So first of all, I want to just use a few namespaces here because there are quite a few and I don't really want to use all of them or constantly type them. So I'm just going to say using namespace LuaCpp, and I'm just going to copy this 2 times and then just go colon registry. Doesn't matter which order these are in, so don't worry. And then engine. I don't constantly want to use these namespaces when I type, so I'm just going to ignore them here by saying using namespace. Now let's start off with creating a simple piece of code just to run a line of Lua code. So first of all, if we want to print out in C++, we use cout. Hello world. As simple as that. Now in Lua, when you call it from C++, it's a little bit different. First, we need to create a Lua context. So we're able to access Lua. So just say Lua context and then just Lua. And then generally you don't have to do this, but it is recommended in case something fails to run. We can just say a try. Then there's our code. And in here we can just say std runtime error. Because it's Lua, when an error is thrown, it will be in runtime because it's not really compiled. And then just &e and then e.what. And then as simple as just saying lua.compile string and run, we can just put some Lua code in here. Print. And take note, if you put double quotes here, it will escape. So put single quotes in here. Easy peasy. And we can just specify Lua. There we go. Maybe just close this here. Now let's quickly wait for this to finish compiling and then we'll install it and I'll show you how to run the code we have just written. Alright, so it's taking a little too long. Yesterday when I tested it, it was like a few seconds. So I don't know why it's currently taking as long as it is taking. So I canceled it. But in your case, you would not cancel it after it has done the installation. What you want to do is you want to say make install. If you're on Linux, you have to say sudo make install because it will need to install to sudo directories if I'm not mistaken. We just say make install and now your LuaCpp folder that we linked in our Visual Studio Code should be there. But in my case, I don't know why this compiling is taking so long. I mean, yesterday was literally a few seconds. So I'm just going to leave it here and you will be able to finish it on your own. You just have to, I guess, be patient. Next up, this is very important. Otherwise, we will not be able to compile our C++ project here. We need to export the path to the location of the SO file in here. So if I go ls and in .so, you'll see we have a lib LuaCpp.so. This is a shared object. We need to create a path that says, hey, the shared object is in this directory. Now, because I didn't finish the build, I'm going to use a build that already exists. So I'm going to mv LuaCpp to LLLL, and then just get my previous Lua file from the trash. Alright, now my LuaCpp will be the original. If we go to build, you should be able to see all of these files inside of build. As you can see all of here. Now this is what you'll have after it completed the build. Now we need to get the path to here. So I'm just going to say pwd, and this is the path we need. So home, netsu, downloads, LuaCpp, build. You might want to move this build folder into your directory here. This would actually make it easier if you were to move it here. So let's do that. Now I already have Nemo. So here in downloads, we can just go LuaCpp, and this build folder, I'm just going to drag it in here. And I'm just going to copy the folder, and there we go. Now this is our LuaCpp. I'm going to rename this to LuaCpp. And this will be able to then find that SO shared object. So now, if we go here, we have our lib LuaCpp.so. Very important. Now we need to export the path to here. Then now what we need to do is we need to say export ld library path. This will be the environment variable that we need to have in order to compile this, because it needs to link to any SO file we need. And we need to link it to this LuaCpp. Now if you put it in this folder, you will have to get this pwd we use here, but just inside of this folder, which might be easier for you. But I'm just going to use it here because it will be easier for me. We just do this, and now we'll have it. If you echo $ld library path, you should see what you just exported in here. If you're on Windows, then the export key will not work. I think you need to use set. Now let's go to this location here. So I'm just going to go to cd documents tuts cpp, and if you wanted to get this LuaCpp folder, you can just say pwd LuaCpp, and I think you have to be in the LuaCpp folder for pwd to get it, and you'll just have to put that in there instead. It's up to you. I might even create a directory inside of my root folder that maybe contains files like this, so it's easy linking. Anyways, however you do it, it doesn't matter as long as you have the path to that SO files folder here. So inside of this build folder, there should be a .so file here. You need that path. Now once you have that, you can start to compile. Now compiling will take a few extra steps, so we have to say gcc instead of g++, but I think g++ will still work. And in main.cpp, because this is our main C++ file, -i to include /usr local include, and then LuaCpp. This folder will exist if you make install that build folder we have. So if you say make install in that build folder, this should exist, this directory. If you want to see what is in there, we can just go ls/usr local include, and you'll notice there's a bunch of things here. In our case, just LuaCpp. If we say LuaCpp, you'll find all of this. Then again, we need to include the Lua development files. This time we can go ls/usr include, and you'll notice there's a bunch of stuff in this include. We just want the Lua, and depending on your version, you will have different Luas here. My development files are for Lua 5.3, so any Lua I write, any Lua code I write inside of the C++ program here can only execute Lua 5.3 code. Anyways, you should see either 5.3, 5.2, 5.4, whichever version of Lua development files you have. I have 5.3. Alright, now we know the path to this. Now we can go here, -I to include again. And now I can just include this. Paste that there. Then we can say -L, and -L means library. So lib and then LuaCpp. So -L LuaCpp is referring to this lib LuaCpp.so. The -L means lib and then LuaCpp, and it automatically knows you want .so. And you want -L for lib Lua 5.3, or whichever version of Lua you included. And then -L stdc++. I have no idea what this means. We just have to add it. -O output. And this will just give us an output file. Alright, great. So once you have this, compiling should take but a few seconds. So just do this and it should be done. If you then run that output file, and here we're having an issue where it cannot find lib LuaCpp.so. That is normal. Let's see what we exported. ld lib, and here we go. There we go. Just added a wrong letter there. It should be library path, not library. Okay. Anyhow, once you do that, now if we compile it again, and this time just run it immediately afterwards. And here we go. Hello world, C++, easy peasy Lua. So this here just ran. All you need to do is you need to export this right here, and then you need to include all of these linking details. Alright. Once you have that, it should be able to run Lua. Now let's get a little bit more complex and run a Lua file. New file, Lua. Now let's go main.lua. Here we go. And let's say print please subscribe and like. Okay. Once you have this, you should be good to go. Just runs Lua, so there's not much to put here anyways. If we were to then go to main.cpp, then instead of compile string and run, we want to say compile file and run. So this will compile a file for us to run. And here we can just pass in the file name, main.lua. As you can see, it's in the same folder as this main.cpp. Now if we were to run this, as you can see, please subscribe and like. You might be wondering what will happen if this output file is not in the same folder as the main.lua. Now let's make a directory, and let's move the output file into X, and let's go into X and then run this output file. As you can see, it cannot run this code. So you need to include this Lua file whenever you distribute this code, because otherwise the file will not be found. So make sure that you include this code with your source code. And finally, let's actually get a good example of what we want to do. Generally, when you work with Lua and C++, you want to include, or you want to be able to like pass variables between Lua and C++ and all of the jazz. Let's do that. I'm going to remove this stdc out here, and I'm going to keep this here, and then right above the try and below the context, we can create a shared pointer. std shared pointer engine Lua t string. This is the type you want to save inside of this variable. In our case, we want to save string data inside of this variable. Generally, in Lua, it doesn't matter what type you put anywhere. You know, you can change it whenever you want. In C++, however, because of how types work, we need to specify we want a string to be stored in here. And later, you should not be changing this to a number or anything like that. There's a lot of things you can store. Lua t string is the same as saying std string. But you can also have Lua t number, which is just for numbers. This is usually a double in C++. So we'll represent a double while this represents a std string. You have t Lua boolean, which is of course just the normal boolean, yes, no, true, false. Lua T nil, which is a nil undefined null value. You have Lua T table, which in C++ is represented as an array or map, usually in std map. And you also have Lua T user data. This is a special type that allows the implementation of user-friendly or user-defined types. And this is very powerful. And then you want to say what the variable name should be in your C++ code. This can be whatever you want. I'm going to say hello world is equal to std make shared, and then engine Lua T string. And in here, you would just want to put the value you want to store in here. In this case, I can just say hello world. This value will now be stored inside of this hello world variable. Now we can pass this hello world variable into a Lua variable. So we can say Lua, and I'm just going to rename this Lua to CTX because it is context. So I'm just going to say CTX dot add global variable. Add global variable will, add a global scope variable. And then you can give the variable name. This is what it will be in Lua. So in our case, we can just say world. So this variable will be called world in Lua. And we can link the hello world variable. Now, what this linking does means that if we change the value inside of hello world here in our C++ code, it will represent it inside of this Lua code. If we change the variable data inside of our Lua code, it will represent it as well inside of our C++ code. So these two are exactly the same. They share the same value. They are shared pointers. If one value changes, it will change all of the other values as well. They're pointing to the same location in memory. One is just available to use in C++, while the other is available to use in Lua. I will test this out a little bit later as well. Then we can go ctx.compile string. And here, this is almost like creating a function call. Whatever you put in here, you can later on call as if it was a function. And let's just say something. And then after that, you can just put some Lua code here. So you can say print saying, and let's append that variable we created, world. Because this world variable is available to use in Lua. So we can use it here. And if you want to add another line, you can either go \n. I don't know if this will cause any errors, but you could also go like this. So these are two separate strings. If I were to just do this, as you can see, they're two separate strings, but they will be interpreted as two different lines. So what we can do now is we can also change the world variable to say something else. This is now Lua code, as you can see here. So this say something and in quotation marks function is basically going to print out what's inside of world and then change it to this value. Then we can just say ctx, and instead of run compile file and run, we can just say run because it's like a function. And when you say run, we can just pass in say something and it will run this say something code. Let's compile and run this and see what we get. Saying hello world. So we're saying and in this value inside of world. Now we want to see the new value inside of world because here we set the new value. To do that, we can just go here and say cout. And then to get the value from C++, we can just say hello world. So the variable we created, get value, as will get the value for us. We can also change the value from inside C++. So hello world set value, and here we can say I am cool, and then we can of course run it in Lua. So ctx.compile string and run, and you can just say print world, so printing that world variable. Now let's try and run this, and you'll see we get saying hello world. Then this is now Lua code. So first we say hello world, then we print it out by just appending saying and then adding world variable here after we attach them. Then we change the world variable to say this is now Lua code. After we run this compile string function, it will try and get the value. And when we get the value, it says this is now Lua code. So we change the value of this variable inside of our Lua code. Then we change it inside of our C++ code and print it out inside of Lua. And as you can see, it also reflected that. So this is how you can pass data between Lua and C++. Create a variable and you can change it from both Lua and C++ and get the value whenever you want. And that is the basics of running Lua code in C++. It's really as simple as that. As I said before, it's not very difficult. The most difficult part of this is just getting the setup right. After you have the setup right, everything else just works. Thank you all for watching. I hope you all enjoyed, and I will see you all again in the next C++ tutorial.